Okay, hello all, and welcome. Sorry, I'm still got a bit of a cold, but welcome to the unit of work on quadratic equations. As a heads up, we'll look at the questions that are set. You'll notice that if you look through this is all the symbolic manipulation of quadratics. So doing the algebra work, none of this is the graphical work on quadratics. You'll cover that in Maths B Advanced class. We're looking purely at the symbolic manipulation. Now, quickly before we go any further, and I think this is still relevant, what is a quadratic equation? We are used to, and we've dealt with previously, you've had an equation, a linear equation of y equals mx plus c, where your m value is your gradient, okay, and your c value is your y-intercept. Now, a quadratic, okay, on the other hand, you'll notice this x is just power to the 1. A quadratic is y equals ax squared plus bx plus c. So we have a power 1 here in our polynomial, but we importantly have a to the power 2 of x here, or a square, and this is what is a quadratic. Quadratic is a polynomial that has the maximum power to the power of 2 for our variable. The a and the b here are not your gradient of any point, because a quadratic, when we graph it, instead of just being a straight line, a quadratic like this, it's a U shape, or if we have a negative quadratic, it'll look like this. Okay? The U or an N sort of shape. A or B do not tell us our gradient, but the C tells us our y-intercept. That's still our y-intercept. That's just a real quick, brief overview of the equations that we're going to be looking at and what they look like graphically, but we're going to deal purely with the algebraic side of things. So as a warm-up, exercise 5a is just a bit of expanding expressions, okay? And we use the distributive law. Now, a bunch of people will know this as they taught in classes or textbooks as using eyebrows, okay? Or whatever other analogy. We multiply whatever's out the front by everything in the middle. This is a simplification of the distributive law, one of the key laws in all of mathematics. It defines a bunch of things, but pretty much it says when we have a multiplication of a term in the front by a bracket, if we multiply everything by the term in the front by everything inside the brackets, that will be equivalent. That's roughly what the distributive law is saying. But we'll do a little bit of warm-up. Hopefully you've done a bunch of this previously. So let's have a go using the distributive law or our eyebrows. So we're going to have 3 multiplied by x and then 3 multiplied by -4. So just to show the full working, plus 3 by -4 is equal to 3x minus 12. Now we'll do the same thing. I'm going to draw in the eyebrows just for reference. So we have -2 times 5, so -2 times 5 plus, and then we have -2 multiplied by -x. Yet -2 by 5 is -10. A negative multiplied by a negative is a positive, so we're going to get plus 2. Now, normally we write the first term. If there's a positive term, we don't like to leave the negative as the first term, so we'll just rearrange this to 2x minus 10. We will do the same here. Now, this whole thing is our first term, so we have half x times by 8x, half x, 8x, minus half x, 5. So half times 8 gives us 4, x times x gives us x squared, and then we have half x times 5, so that will just be 5 onto, or half of 5 by x. Now, this one over here, we have 2 sets of brackets. What do we do? We just apply the distributive law twice. This is still a term, and when there's just a sign in front of brackets, okay, it's just mathematicians being efficient, not lazy, we're being efficient, and there's just a hidden 1 there. So this is a -1 that we can use by the distributive law, and then we can do the distributive law again here. So we get -1 times by x minus 1 times by 3 plus, in this case we get x3 plus x times by negative 5y. Now, it's not expected that you'd do or show all this working out. It's obvious that you can do this basic multiplication in your head, so you could write this much shorter, but I'm just leaving all the working out so you can see the process. So we get negative x minus 3 plus 3x minus 5yx, and we will collect like terms because we have a 3x and a negative x, so we get 2x minus 5yx, and we generally stick our constant term on the end. You normally put any terms with variables first and stick your constant term at the end, just as routine process. So that's just a quick review of the distributive law. Okay. Now quickly with the like terms up here, I did sort of skip that, my apologies. Okay, we can, like terms have the same pronumeral and the same pronumeral to the same power. So if we had a term that was 3a plus 5a, that is fine, we can do that. We have 3a's plus 5a's, we get 8a's. But if we had 3a plus 5a squared, these are not like terms. The pronumeral, the letter or variable here and here, even though they're the same letter, they have a different power, so they're not alike terms. So as it says here, 5x and 3x could be added or subtracted, but 6y and 10x cannot be added or subtracted because the pronumeral or variable is. Okay, expand and simplify the following. This is a bit larger, and this is doing what we call binomial products, okay, because we have effectively two binomials. Binomial is an expression with two terms. So there's one binomial, there's another binomial. So how do we do this? How do we apply the distributive law? Because we have the same thing. We have bracket times bracket. Some people will be taught FOIL, okay, which is first, outside, inside, and last. And what this is referring to is you multiply to the first in red. Okay, so we multiply the first terms. Then we multiply the outside terms. So we multiply those two. Then we multiply the inside terms. That, and then we will multiply the last terms. That. So we end up doing 4 multiplications. What this is doing realistically is the binomial expansion, or the distributive law, and it's multiplying everything in the first term by everything in the second term. Doesn't matter how long your terms are, you can do the same. So let's have a go at this. So 2x times, I'll write it in full first, so 2x times x, that's our first. Now we'll do our last, plus 2x by 2, that's inside, plus 3 times x, plus 3 by 2. So that gives us 2x times x is 2x squared. 2x times negative 2 minus 4x. And we have 3 times x, so plus 3x, plus 3 times negative 2. So minus 6. Now, most of these binomial expansions, especially if they're just using the same variable, so in the first set of brackets we have an x, in the second set of brackets in the x, we normally end up with 2 like terms in the middle that will always simplify. So in this case, we have equals 2x squared minus x. We simplified those 2 terms there. Now, x minus 2 squared, if you remember from the surds, there is a shortcut for this expansion, because if we pull this out, we have x minus 2, x minus 2. Okay? But when we ever have a set of brackets squared, and I'll put the quick rule up here, if we have a minus b squared, we can get a squared minus 2ab plus b squared. That's the shortcut to expand this. You could write it like this over here. Okay, you can write an expanded form first, then expand both the brackets, and then collect the like terms, and you'll get something with 3 terms over here, or you can just use this shortcut. So let's use the shortcut because we always want to be efficient. So we have x minus 2 all squared. So we square the first term, x squared. And this is the bit most people forget, is the bit in the middle. We're going to multiply the first term by the second term, then multiply by 2. So x by negative 2 is negative 2x. Multiply that by 2 again, which is this 2 there, gives us negative 4x. We get x minus 4x, and then we square the last term, so plus 4. And that's it. If you did this and then did FOIL, you would get the exact same answer. Okay. Now on to C. If I can get my eraser, there we go. Okay. Oh no, now my pen's gone funny. Ooh, I'm crazy. Right, sorry about the mess. I'm going to leave it there because I don't want the pen to go crazy again after using the eraser. Here we have binomial expansion. Okay, bracket multiplies by a set of brackets. This again, if you recognize from surds, this bracket, the first bracket is exactly the same as the second apart from the signs. Remember the rule for that. If we have a minus b multiplied by a plus b, okay, the two terms in both brackets are exactly the same, it's just the signs are different. This is going to be the same as a squared minus b squared. We can take the shortcut, so let's do that. Our first bit is 3x, we're going to square it, minus our second term is 4, we're going to square it. So this gives us 9x squared minus 16. And this one, it looks complicated. You could do FOIL. We're going to have to do a little bit of FOIL. Actually, we're going to have to do FOIL across the whole thing because this first bracket is different to the second bracket, so we can't use our shortcut. And same over here, this bracket is different from the bracket here. So let's work on the first bit underneath. So we got, I'm going to do FOIL without drawing it in. I'm going to do the operation straight away. So x times x is x squared. That's our outside. Our first, sorry. Now outside will be x times negative 3, so negative 3x. Inside terms will be 1 times x, so plus x. Last terms, 1 times negative 3. It's 3 minus, and I'm going to put in a bracket here because this negative applies to all of this. A lot of people will make sign errors here. So 2x times 2x will be 4x squared. That was our first. Outside, 2x times negative 3 will be negative 6x. 1 times 2x is 2x. 1 times negative 3 is negative 3. Get x squared. Collect the like terms here in the middle. Will be minus 2x minus 3 minus all this bracket, we get 4x squared. Again, we're going to collect the like terms in the middle. Negative 6x plus 2x, so minus 4x minus 3. Let's apply that negative sign all the way through the brackets now. So we got minus 4x squared plus 4x plus 3. And collect like terms, x squared minus 4x, we get negative 3x squared. Negative 2x plus 4x, so that's plus 2x, and negative 3 plus 3 is 0. So that is our answer there at the end. Okay. We generally write the term with the second power, okay, power to the 2. We generally write that first. Even though it's a negative sign, we'll always write the order to the power of 2 first, then our linear term, and then our constant at the end. So we have it in that ax squared plus bx c form. Okay. Power 2 first, then linear power, and then our constant at the end. That's expanding binomials. Okay. So like I said here, this example here, because we've done it before in our surds and indices, okay, there's that shortcut. Okay, that shortcut is called perfect squares. X minus 2, okay, can be identified as a perfect square. The clue is it's 2 identical brackets, and there's the shortcut to expand that. If we have a plus b, so the key thing here is plus, we get a addition and addition. A plus b all squared, we get an addition, addition. And the key bit in the middle, and everyone forgets this, they'll see x plus 2y all squared, and they'll go, oh, that's x squared plus 4y squared. We just applied square to each term individually. We know if we do FOIL though, we get this bit in the middle after we collect like terms, which is the first term multiplied by the second term times by 2. And this other shortcut over here, if we have a minus b, a subtraction all squared, the difference over here is this subtraction sign. Okay, for our middle term. The second term ends up still being positive because it's what it is b times b, and negative times a negative gives us a positive. That's there, and we can apply it. X minus 2, so square the first term is x squared. Our middle term is x times by negative 2 times by 2, and then plus 2 squared at the end, so x squared minus 4x plus 4, which is what we... So let's apply it. Okay. Square the first, multiply the two terms, times it by 2, then square the third. So we can go x squared, okay, and we're going to have plus, and I'll write this out, 3 by x times by 2, and plus 3 squared. Bit in the middle is really important. We get x squared plus 3 times 2 plus 6x plus 3. Let's do this one over here. So square the first term, so 2x squared. Then it is negative 3 times by 2x times by 2. We always have to double it. Okay. And then our second term squared, so negative 3 squared will be plus 9. This is 4x squared. 3 times 2 times 2 will be minus 12x. This one, okay, square our first, 3x all squared plus 2 times by 3x times by 5y, and then square our last term. This gives us 9x squared plus 2 times 3 is 6 times 5 is 30xy plus 25y squared. That is much quicker than doing FOIL. Much quicker than doing FOIL. Okay, difference of perfect squares. Like I said before, if we go back, that's this one over here. We have two identical brackets, but with different signs in between. One subtraction, one addition. That is, we did perfect squares. This is now called difference of perfect squares because we have a difference in it. Subtraction and an addition. The shortcut for this is even easier. Square the first, take away the square of the second. So in this case, 3x minus 4, 3x plus 4. First term's the same, second terms are the same. One's a subtraction, one's a positive. Square the first, square the second, there's a subtraction. So we can apply that really quickly. So first terms are the same, second terms are the same, so we can use that. So we get 2x all squared minus 1 all squared. So that is equal to 4x squared minus 1. Now you can do FOIL. FOIL will always work. You grind out some maths like I do in some topics, you can always use FOIL. But it's great to recognise these shortcuts because come later years, such as math methods or specialist math, it's all about time. 1, you need to be good at the maths, but 2, you need to be quick at the maths. So any shortcut is great to use. Let's check. First terms are the same, second terms are the same. It's a subtraction and addition. So it is 5a all squared minus 2b all squared. We get 25a squared minus 4b squared. Now we look at this one. X, 3x, oh that doesn't work. 2, that sort of works. What we want to notice is it's this term and this term. So we can write it as x minus 2. X plus 2, 3x plus 2. We can change the order of multiplications because multiplication order doesn't affect the answer. So we're going to use the shortcut on this first term. So we first two binomials. So we'll get x squared, or 2 times 2. Then that's multiplied by our 3x plus 2. And from here, we'd use our FOIL. We're going to get first is 3x by x squared. Outside is plus 2x squared. Inside is negative 4 by 3x. That's going to be, you can see it. And then 2 here. So we get 3x cubed plus 2x squared minus x minus 8. And there we go. Cool. So that is it for exercise 5a, which is just looking at expanding expressions. So to quick review of what we looked at was a quick review of the distributive law, which means multiply whatever's term in front by everything in the brackets. We then brought that onwards to binomials, which is 2 terms in brackets multiplied by another 2 terms. And then we recognized a few shortcuts, which is our perfect square shortcut, where it's just a set of 2 terms all squared, and you can't forget this middle section. And then we had difference of perfect squares, which is 2 sets of brackets exactly the same, but the signs are different, and it's a really good, easy shortcut to use. Any questions, post them on the Google Classroom or Compass. Thank you very much.